In 1995, a wildfire tore through a forest in northern Canada. It burned for weeks. It left behind nothing but ash, dead trees, and silence. The government made a decision that surprised everyone. They walked away. No replanting, no cleanup crews, no intervention, just silence. For 30 years, that land was left completely alone. Scientists expected a slow, painful recovery. Maybe some scrub brush, maybe a few pioneer weeds. What they found instead stopped them cold. The forest didn't just come back. It came back wrong. Or at least, that's what they thought at first. Because what was growing in that burn zone wasn't what any textbook predicted. The species were different. The soil chemistry had shifted. Even the animals that returned didn't match the ones that had been there before. And at the center of it all, one organism that no one had been tracking. An organism that had been quietly rebuilding the entire ecosystem from underground. Without any help, without any human intervention, without anyone even noticing. This is the story of what happens when nature is left completely alone. And why what grew back in that Canadian forest may have changed everything scientists thought they knew about recovery, fire, and time. In northern British Columbia, the summer of 1995 was brutal. Weeks without rain, temperatures pushing past anything normal for that region. Then a lightning strike hit a ridge near the Boron River watershed, and everything changed. The fire spread fast. Within days, it had consumed over 40,000 acres of boreal forest. Spruce trees that had stood for 200 years were gone in hours. The smoke could be seen from space. When it was finally over, provincial forestry officials flew in to assess the damage. What they saw looked like the surface of another planet. Black, silent, total. One of the lead surveyors, a man named David Calloway, later said it was the most complete burn he had seen in 30 years of field work. Not a single living tree left standing in the core zone. The soil itself had been scorched several inches deep. Normally, after a burn like this, the government moves in. They plant seedlings. They seed the ground. They try to fast-track recovery. It's expensive, but it's standard practice. But something unusual happened this time. Budget cuts, political shifts, a new provincial forestry review that froze replanting programs across the region. The boron burn zone simply fell through the cracks. And then the years started passing. 1 year, 5 years, 10. Satellite images showed almost nothing growing back. Researchers who glanced at the data assumed the site was a long-term loss. They moved on to other projects. Nobody was watching, which is exactly why what happened next went undetected for so long. In 2024, a doctoral researcher named Marcus Elroy was combing through decades of satellite data at the University of British Columbia. He wasn't looking for anything dramatic. He was building a baseline study on long-term fire recovery across boreal zones. Routine work. Then he pulled up the boron site, and he stopped. The images from the early 2000s showed almost nothing. Bare ground, scattered ash debris, a few patches of frost-killed moss. But then something started appearing around year 12. Not where the trees used to be, not along the edges, where recovery usually begins. In the center, the most completely burned section of the entire zone. That made no sense. Recovery biology doesn't work that way. The harshest zones recover last. Everyone knows that. But here, the interior of the burn was showing biological activity before the outer edges. Elroy flagged it as a data anomaly and moved on. Except he couldn't stop thinking about it. He pulled ground-level survey reports from the area going back 15 years. Most were incomplete. A few were missing entirely. But one report, filed by a provincial land monitor named Greg Sutton in 2011, had a single strange note buried in the appendix. It read, "Unusual fungal network detected in core burn area. Origin unclear. Recommend follow-up." There was no follow-up. Sutton had retired the following year. The note had sat unread in a provincial archive for over a decade. Elroy read it twice. Then he booked a flight north. What he found when he finally reached that burn zone in person was something no satellite image had prepared him for. The drive into the boron watershed takes hours. No paved roads past a certain point. Just gravel, mud, and silence. Elroy reached the outer edge of the old burn zone on a gray morning in early spring. He expected devastation. 30 years later, he thought there might be some scrubby regrowth. Maybe young spruce. Maybe low shrubs clinging to the slope. What he walked into looked nothing like that. The trees were tall, not saplings, not pioneer brush. Full canopy trees, some already pushing 15 to 20 meters. But that wasn't what stopped him. It was the species. These weren't the spruce and pine that had dominated the forest before the fire. The dominant trees were birch and aspen, interspersed with species that had no recorded presence in that watershed before 1995. Elroy pulled out his soil sampling kit and dropped to his knees. The ground was soft, unusually soft for a formerly scorched site. And when he dug just a few centimeters down, he found it. A dense, white, thread-like web running through the soil in every direction. Mycorrhizal fungi, but not just any variety. A strain that, according to every survey on record, had never been documented this far north. It had no business being there, and yet it was everywhere. Elroy sent samples back to the lab. The results came back 3 weeks later. His supervisor called him directly. He said only 4 words before the technical explanation. 4 words that reframed
This predates
everything.
the fire.
This predates the fire. The fungal network hadn't arrived after the fire. It had survived it. That should have been impossible. The core burn zone had reached temperatures exceeding 800 degrees Celsius in places. Soil at that heat doesn't just kill organisms. It sterilizes everything for years. And yet this network had not only survived, it had expanded. Elroy's supervisor, a mycologist named Dr. Peter Vance, flew in 2 weeks later with a full research team. They set up a grid across the entire core zone. What they mapped over the following months was something that had never been formally documented in boreal forest science. The fungal network had acted as a scaffold. While the surface was dead and barren, underground the network had been quietly pulling moisture, fixing nitrogen, and restructuring the mineral composition of the soil. Year by year, layer by layer, it had essentially been rebuilding the ground from the inside out. And it had been doing this completely invisibly for over a decade before anything appeared on the surface. That explained the anomaly Elroy had spotted in the satellite data. The interior recovering before the edges. The network was densest at the center. That's where it had started. That's where it had the most time to work. But then Vance found something that shifted the entire story. While cross-referencing the fungal strain with historical soil archives, he discovered a sample match. A sample taken 40 years ago, from a different burn site, 300 kilometers away. Same strain, same behavior, same pattern of invisible underground recovery. Someone had documented this before, and the report had been quietly shelved. The shelved report had been written in 1987. A forestry researcher named Alan Marsh had documented the same fungal strain after a burn site in the Mackenzie River corridor. He had flagged it as significant. He had recommended urgent follow-up research. The recommendation was acknowledged, then buried under budget reviews and departmental reshuffling. Marsh had died in 2003. His findings had never been published. For nearly 40 years, the information had sat in a provincial archive box in Edmonton, unread. When Vance and Elroy pieced the timeline together, the picture that emerged was both remarkable and quietly damning. This fungal network wasn't rare. It was possibly widespread across the entire boreal zone. It had been surviving fires, rebuilding soil, and rerouting forest recovery for decades, maybe longer. And every time a human replanting crew moved into a burn site within the first few years, they were unknowingly disrupting the process before it could take hold. The interventions meant to help were cutting the recovery short. The boron site had only succeeded because no one showed up, because the budget ran out, because a political review delayed the crews, because the land fell through the cracks. The forest had recovered not despite being abandoned, but because of it. Vance presented the findings at a forestry conference in Vancouver in late 2024. The room was quiet for a long moment after he finished. Then the questions started. Hard questions. About replanting policy. About intervention timelines. About how much money had been spent doing exactly the wrong thing for decades. Nobody had clean answers. What they had instead was a single burned valley in British Columbia. 30 years of silence. And a forest that had rebuilt itself in the dark. If this story made you see the natural world a little differently, you know what to do.